Hi everyone, I am Sandhya, Assistant Professor, Department of Mathematics in SNS College of Technology. Today we are going to see about the Unit 2 Standard Distribution. So in the standard distribution we are going to see binomial distribution, exponential distributions, and Poisson distribution, uniform distribution and normal distribution. Okay, so in this class we are going to discuss about the first distribution, that is binomial distribution. In this binomial distribution is a discrete distribution. So in this discrete distribution there are three discrete distributions are there. First one is binomial distribution, and the second one is Poisson distribution, and third one is geometric distribution. Okay, so in this binomial distribution we are going to see the definition of the binomial distribution. So in this binomial distribution we have to using the Bernoulli trial. So in this Bernoulli trial has two possible outcomes called the success and failure. So success is denoted by S and failure, that is denoted by here the success is denoted by that is P, and failure is denoted by that is Q. So here the small p and small q. Small p is success and small q is failure. Such a trial is known as Bernoulli trial. So next we are going to see the binomial distribution. So in this binomial distribution, a random variable x is said to be a binomial distribution if it is assume only the non-negative value. So here we are going to assume the non-negative value of its probability mass function. So it is a discrete distribution, so we are going to use the probability mass function. So probability mass function is denoted by P of x. So here the formula is NCX P power x Q power n minus x. Here x varies from 0 to n, and the probability P plus Q value is exactly equal to 1. Next we are going to see the properties. So in this properties there must be a fixed number of trial. So here n value is fixed. N is how many tasks? There are 8 tasks. So here n is fixed value. Then second one is all trial must have identical probability of success. Here the identical probability, the success value is P. The trial must be that is independent of each other. So the trial is independent of each other. Okay, then we are going to see the moment generating function of the binomial distribution. So in this moment generating function, it is a discrete random variable. So mx of t is summation x equal to 0 to infinity e power tx into p of x. Here the p of x. What is the p of x? P of x is ncx p power x q power n minus x. So here we want to substitute p of x is ncx p power x q power n minus x. Then we have to combining e into p. Okay, so that is p into that is e t whole power x ncx that is q power n minus x. Then we have to substitute n values, that is what is x value is 0 to n, that is nc 0 q power n plus nc 1 pet whole power 1 q power n minus 1, so and so on. Then after the simplification we get the moment generating function of the binomial distribution is q plus pet whole power n. So you got the formula, that is q plus pet whole power n. Then we have to find the mean and variance. So mean is expectation of x and variance is variance of, that is v of x. Here we have to using the formula d by dt mx of t. The mx of t. What is mx of t? That is q plus pet whole power n. Then substitute here. Okay, then we have to differentiate with respect to t. So here what is that? n into, after differentiation with respect to t, n into q plus pet whole power n minus 1. Again we want to differentiate with respect to t, p e power t, then substitute the value t equal to 0. So e power 0, the value is 1, so we get the np into q plus p whole power n minus 1. So n that is p plus q value is 1, we have to substitute here, so the mean value is np. So using this np we have to find the variance. So what is the variance formula? Expression of x square minus expectation of x the whole square. So here expectation of x, that is mean value is known, then we have to find the expectation of x square, that is d square divided by dt square mx of t at t equal to 0. Here we want to differentiate second order, then differentiate with respect to t. So the value is np q plus pet whole power n minus 1 into e power t n minus 1 q plus pet whole power n minus 1. Then we have to substitute t equal to 0. Then the answer is np into 1 plus n minus 1 into p. Okay, then we have to multiply np into, so np plus n square p square minus np square, this is expression of x square. Then we have to substitute mean value and expression of x square value. Finally we get the value, variance of x is npq. So here the moment generating function is q plus pet whole power n, the variance, that is mean value is np, variance value is npq. So this is the binomial distribution, moment generating function, mean and variance. Thank you.